Hi folks, Mr. Long here. This is going to be the fourth video in a series of videos on what are called Riemann sums. Riemann sums, the goal of the Riemann sum is to determine to estimate the area under the curve for some sort of function. Very, very commonly used because you don't always have a nice function to work with. Sometimes you'll just have a set of data points that you're working with, okay? So the last one we're going to do is called the trapezoidal rule. Now, we know a trapezoid, right? To get the area of a trapezoid, we would do this. So if this right here would be a trapezoid right here, right? So say that width was 2 from there to there. Say this height here was 6, and this height here is 8. Well, there's definitely formulas for it, but the easiest way to do it, I think, with a trapezoid that's shaped this way, because they can be shaped a little differently, is just to get the average height. So what's the average height? 6 plus 8 is 14. And then, so that would mean this would be if I turned it into a rectangle, right? Because these are, if it was perfectly linear, which curves aren't, but if it's a trapezoid, it's perfectly linear, then this would be our overestimate there, that would be our underestimate there in terms of just calculating the area of a trapezoid. It would balance off perfectly, right? So the area is just going to be base times height, which is our average height. The base is 2. The average height here is 7, which gives us 14, okay? So that gives us 14. So that's how we do the trapezoidal rule. But I just get I call it more the average height rule. So add the heights together and divide by 2, or add the y values together and divide by 2. So let's start going through this. Okay, let's start going through this. Again, pause, rewind, go over these videos when it doesn't make sense. N equals 3 still, 3 subintervals, and we're using the trapezoidal rule. So now this is one that you can, this one you can actually do the graph right away because it's pretty easy to see. So what you're really going to do is you're going to start at 0. We know we've got 3 intervals, and we figured out delta x is 2. So really what you do is, to draw your trapezoid, you just go 0 to 2, 2 to 4, and join up the y values, and then from 4 to 6 join up the y values, and you can see how we get these trapezoids. Okay, so this is your A1 is below there, your A2 is below there, your A3 is below there. Now, in terms of underestimate and overestimate here, well, it gets a little more complicated, and it relates to something called concavity, which is the degree to which a function is smiling or frowning, right? We call that concave up, and that is concave down. So the concavity plays a role in the estimate, but I think you can see when you look at this that the estimates are going to be, it's going to be a pretty accurate estimate when you use a trapezoidal rule. Okay, so again, it's the average, I call it the average y value rule. So first box is going to go 0 to 2, second rectangular box goes 2 to 4, x equals to 4, and the last one goes x equals 4 to 6. So delta x is 2. Oh, 2, 2, and 2. So each rectangle is 2 wide. How tall is each rectangle? Well, I've got to get the average y value. What's the average? So I go from the left to the right, and I add them together and divide by 2. So 0 plus 4 is 4, divided by 2 is 2. Next one. 4 and 16. So the left side has a y value of 4, the right side has a y value of 16. And 4 plus 16 is 20. What's the average of that? 20 divided by 2 is 10. And in the last box or rectangle, I go from x equals 4 to x equals 6. And the y values are 16 and 36. Well, what's the average y value if I'm considering 16 and 36? Add them together. 16 plus 36 is 52, divided by 2 is 26. Okay, so just make sure I've got that right. Yep, that's right. 36 and 16 is, in fact, 52. 52 divided by 2 is 26. So those are now the f at x values I'm going to use. That's the height of each rectangle. Okay, so the height of the first rectangle, 2. The height of the second rectangle, 10. The height of the third rectangle, 26. Now, if I was actually going to calculate the areas here, what would it be? Well, 2 times 2 is 4, plus 2 times 10 is 20, plus 2 times 26 is 52. 52, and when you're adding, by the way, you should always add larger numbers to smaller numbers. So I would go 52 plus 20 is 72. 72 plus 4 is 76. Okay, 76. Okay, so that's the trapezoidal rule. The average y-value rule is what I call it. Let's look at a summary now. Let's look at a summary. So this was 76, which means the error is plus 4. So look at this. I did hopefully you did these calculations. The left-hand rule calculated out an area under the curve of 40. The actual answer is right there, 72. So I'd used, so the way I did that is x to the n plus 1 over n plus 1 evaluated at x equals 6, right? So all I had to do was x cubed over 3 at x equals 6. Okay, so I subbed in 6. 6 cubed over 3, and that gives you 72. So if the proper answer, or the exact answer, is 72, the error with the left hand is minus 32. That's an underestimate. 112 is the right-hand rule. That's an overestimate of 40. The centered interval actually gives the smallest error, in this case, minus 2, and the trapezoidal rule gives an overestimate of plus 4. But you can see just how much better the centered and trapezoidal rules are than the left-hand rule and the right-hand rule. Now, please don't get them confused. These are very different rules. The centered interval means you find the center of the interval in terms of x, then you look and say, what is the y value there? And that's your height. The trapezoidal rule adds together the y values on the left and right side of the box or the rectangle, divides by 2 to get an average y value. So again, trapezoid is average y value. Centered interval means get the y value at the center of the interval. Okay, folks, so maybe you can hear my dog barking. I apologize if you can hear that. Anyway, so that's what we did. We worked through all 4 different methods: left hand, right hand, centered, and trapezoidal rule. And now you should be able to use a Riemann sum to estimate the area under any curve.